Grade 12 learners, welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, our WhatsApp number is 079-578-2908, grade 12, 079-578-2908. You are more than welcome to send your clarity-seeking questions to that particular number or any alternative solution that you'd like to share with us. And then today we are looking at differential calculus. And then under calculus, we'll be looking at the three subtopics. The first one being the first principle, followed by the rules of differentiation. The last one will be the equation of a tangent. And then after the completion of this lesson, you will be able to differentiate using first principle the functions defined by the following. F at x equals to k. What do we mean by that, grade 12? We mean where we are given an equation that is a constant number. For an example, if you are given f at x equals to 2, maybe. That is what we mean. The value here must be a constant number. What do we mean by a constant number? It's a number without an x, okay? And then now the second function is f at x equal to ax. What do we mean by that? We mean, for an example, if we are given now f at x, now this is equal to 2x. It's a constant plus an x now. That is the equation we are referring to with ax. That means this a can be any value. Also from the first one, this k can be any constant number. Okay, and then thirdly, if we are given f at x equal to ax plus b, for an example, what do we mean about this one? It's when we are given the f at x being equal to maybe 2x plus a number added to that one. That means the a and b here are representing numbers, okay? And then now, secondly, you must use the rule of differentiation. You'll be able to use the rule of differentiation to derive using the rule of differentiation. Remember, this rule states what, grade 12? If I am having 2x to the power 10, the rule means you multiply 10 by 2, it will be 20. X, and then from the exponent you subtract 1, then you'll be left with n. So this is the explanation that is given to us in terms of that particular rule there. And then n must be an element of real numbers. And then thirdly, you will be able to determine the gradient of a tangent to any graph and the equation of a tangent to a graph. So now it's a gradient plus an equation of a tangent. And remember, grade 12, when you talk equation of a tangent, you are referring to a straight line. Since a tangent is a straight line, then it is using exactly the same equation as the one that we are using for determining the straight line graph equation, okay? And then the pre-knowledge that we need here, you must know the formula to find the gradient, that the gradient is equal to y2 minus y1 over x2 minus x1. Remember, we use the symbol m for the gradient now. It's m equal to y2 minus y1 over x2 minus x1. And then to find the equation of a straight line, you use the original straight line y equal to mx plus c. Or if you don't use that particular one, you can use the y minus y1 equal to m into x minus x1. It doesn't matter, grade 12, which one you choose, you will end up with the correct answer for both. And then to determine this equation of any straight line graph, you need a gradient and a point. That means you need the value of m, and then you need a point that is having a coordinate. That means that is having the value of x and y. And this point must lie on the graph, okay? Or it must be an equation with a tangent. It must be at the point of contact to that particular graph, okay? And then now if f at a is equal to 0, That means you are having your f at x function, and then from the f at x function, you have now substituted your x with a certain value there, which is represented by a there. If when substituting the x value there, your answer becomes a 0, that means x minus a coming from that value substituted there, is the factor of that f at x function. Okay, and then do not confuse the following. For an example now, if you are given f at x, look at that, the original from f at x function given to you. If you substitute your x with any value, in this case you have substituted with a positive 1. Is the original f at x as it is? We substituted 1 for x. That means you are looking for the y coordinate, okay, where x is equals to 1. The value that you'll get there after substituting a 1 in your f at x, it will be your y value. And then now you can write this in coordinate x is 1, and then with the y value that you will get after calculating them. But if now it is f derivative, it is having that dash on top there. This is now the gradient. You are now looking at the gradient where x is equal to 1. That means grade 12, you must start by looking at the derivative of this function here. You start by deriving your function f at x. After deriving, now you substitute that with a 1. That is what we mean about that. The minute you have followed that method, that means you are looking for the gradient now. Gradient at x equals to 1. We are looking at the gradient at x equal to 1. And that gradient is the one that we say is the gradient of a tangent to that particular graph at a point of contact. Okay, we will elaborate more on this one when we are doing the equation of a tangent. And then now we have a pre-knowledge on derivative notations. We are having different notation to indicate that we are deriving. If we are given f at x original, then you'll be having f derivative. We must have that dash to tell us now you are starting to derive, or you are looking for a derivative. Another notation is a dy dx, or a d into dx of a function, or the dx of a particular function. That means grade 12 now. If I am given my function as being f at x, the minute I start deriving now, my notation will be f derivative of x, because I'm now deriving. If I'm having dy dx, okay, let's start here. If I'm having an equation y is equal to something, the minute I derive, this will be dy dx. I am telling you that I am deriving now. Okay, if it is given as d dx of a function f at x, any function there, the minute I start deriving now, I will be focusing on the equation only. I do not write that dx anymore. The same applies with the third one. If I am given as dx into the f at x function, the minute you start deriving notation, you lose that dx grade 12 at the stage where you are deriving. So it is very important, grade 12, that you indicate this notation correctly, so because if you do any mistake, you will be penalized 1 mark for notation throughout your differential calculus. And then now, before you derive grade 12, you need to simplify the function as far as possible, ensure it is in its simplest form, okay? And then now you must also check what? Change all sets to exponential notation. For example, if I'm having a cube root of x squared, yeah, I need to change this to x to the power 2 over 3. Remember that root sign becomes a denominator now. That is what we mean about changing all your sets to exponential form. And then you multiply all the brackets. For an example, if we are given your f at x as x plus 1, but now this bracket is squared. You can't derive this grade 12. You must start first by multiplying the brackets out. So we'll end up with the what grade 12? The x squared plus 2x plus 1. It is only then that we can derive this function. And then bring all variables in the denominator to the numerator and then change sign of the exponent. What do we mean about that one, grade 12? We mean now, if we are having maybe 2 over x here, you cannot derive that. You must take the variable in the denominator to the numerator, okay? And remember, it was positive 1, that is why it's changing sign there. That is why we say change sign of exponent as you move your x to the top. All right, great job. So basically, that is what you need to take care of before you start deriving. And then now here you have your baseline assessment, grade 12. I want you to answer these 4 questions just to check the baseline before we continue with the lesson of today. I am giving you 3 minutes, grade 12, to look at this baseline assessment. And then after 3 minutes, we will look into the solution. Your 3 minutes starts now. Okay, great, Charles. Let's see how far did you go with this one. Remember to send your clarity seeking questions to 079 578 2908. Now, if you look at this, we are given that f at x is equals to 2x plus 3. When you look at number 1 now, they say determine the following. Number 1 is f at x plus h. if you compare your f at x with this one, you can see where you have an x now, we have substituted x plus h. That is exactly what we will be doing, grade 12. We take this equation as it is, and then where we have an x, you are going to put x plus h, substitute x plus h now for x. So we end up with f at x plus h being, distribute 2 in there, multiply in is 2x plus 2h plus 3. You can't multiply this 2 to 3, grade 12, because 3 is not inside the bracket. This 2 is only multiplying x plus h, right? So that is your f at x plus h. And then this will be 1 mark, grade 12, for the correct answer then. And then number 2, now you are looking at f at x minus h. If we look at this part here, this is what we have done already in number 1. You do not have to repeat that. And then we are subtracting the f at x, of which is what is given to us there. Okay, let's do the substitution now. F at x plus h minus the f at x. What is f at x plus h now? Is 2x plus 2h plus 3. 2x plus 2h plus 3 minus, remember, the minute you have a negative and you have to substitute something, ensure that you put that bracket. It is very important, grade 12, to put that bracket next to your negative there. Because now if you look at f at x is 2 times, which is 2x plus 3 there. So this negative now is going to affect both of them. So you end up with 2x plus 2h plus 3. We are now going to multiply the negative in onto both times. It will be minus 2x minus 3. Final answer, 2x minus 2x, a 3 minus 3, that is giving you a 0. So you'll be left with only 2h. That means the first mark will be for correctly substitution, second mark for simplification, the last one for the answer there. That means your number 2 is 3 marks, grade 12. And then look at number 3 now, we are continuing. Number 3 is saying take f at x plus h, of which is the answer for number 1, minus the f at x, that is the answer for number 2, of which is 2h that we have just calculated. The top part there, we have already calculated and have the answer being 2h. And then they are saying now take that answer, because we have f at x plus h minus f at x all over h. So the top part you have already calculated is 2h, and then divide by h. The h will cancel an h. We are left with only 2, grade 12. So now the first will be for simplifying or substitution of the correct answer there, and for the final answer, of which is equals to 2. And then lastly, number 4. Now we are looking at this formula. I hope you are not seeing this for the first time. This is the formula we are heading to, of which is the first principal formula. And then you'll find this formula at the back of your formula sheet, grade 12. That means now we have done partially, so scaffolding how you will be able to answer this question easier for you. That means step number 1, number 2, number 3, it was leading us to this particular formula, of which you can see that what we have on number 3 there, that is what we need to substitute there. Okay, but you can't get that without following step 1, step 2, and then your step 3. So now let's take the derivative formula. F at x is equals to the limit of h approaching 0. And then now we have the value of f at x plus h minus f at x over h from number 3, of which is equals to 2. So we'll take it from there, grade 12, that this is equals to 2. And then now the limit of h approaching 0 will be that 2 now. look at the answer. You don't have a limit anymore on your notation there because that is your final derivative of that function equals to 2. Then this will only be 1 mark for the final answer there. Okay, so now if we talk first principle, this is the combination of this method from number 1 up to number 4 now. I hope it is clear to everyone now, grade 12, and then you really made it up to this point where we have to end up with the first principle. And then now the terminologies that we'll be talking to in this topic, we are talking the instantaneous gradient. Instantaneous gradient is the derivative gradient at a specific point. That means it's a gradient at a specific point. That means now it's a gradient of a tangent to a particular graph. For example, if you have a parabola and then there's a tangent graph that is touching that parabola at one point like that, this is the instantaneous gradient that we are talking to at that particular point there. And the limit of the average gradient is the value that the average gradient approaches. So we are limiting. Remember on the previous, we say h approaching 0. To approach, you are becoming very closer to a certain point. That means the limit of the average gradient is the value that the average gradient is approaching. And then differentiation is the process of determining the derivative of a function. When you determine a derivative, you are busy differentiating. And then the tangent is the line that touches the graph once at a point of contact. It doesn't matter which graph, it can be a cubic function. As long as it is touching that graph at one point, then the line will be a tangent at that point of contact. Okay, now the first topic we are looking at, first principle. This is the formula, and the formula, you find it at the back of your question paper on the formula sheet. Ensure that grade 12 you copy this correct, because the mistake that you do now, most of the time you miss that point there that is showing that it's a derivative, and then sometimes you omit this limit, you forget there's a limit there. And then another mistake that you do, you normally take this equal sign in front of the limit, of which is incorrect notation. So before we can do anything, let's ensure that we copy the formula correct from the formula sheet, because it is there at the back of your question paper. Now here we are given them f at x equals to 10. This is a constant number. Do you still remember that the derivative of a constant number, grade 12, is 0? But if they say use the first principle, they say use this rule here. And if you look at this rule, it needs f at x, of which it is what we are having, but it also needs the f at x plus h, right? Now, remember now, if it is f at x plus h, okay, let's start here now. If it is 10, that means this was originally 10x to the power 0. Why? Because x to the power 0 is equals to 1. Therefore, this is 10 into 1, of which is still a 10. That is why we are having f at x equals to 10. So if you try to look at f at x plus h of this, let's see now what is happening. Because when we have x now, we are going to substitute x plus h. This is 10 into x plus h, but remember the whole thing is to the power 0. Any number to the power 0 is equals to 1. This is still giving us the 10. So your f at x is exactly the same as your f at x plus h. That means it is 10, 10, only for the condition where you are having a constant number, okay? And then now into the formula, f derivative of x, the limit of h approaching 0 of f at x plus h, we are substituting into that formula, grade 12. F at x plus h is 10, f at x is also 10, and then all over h is the limit of h approaching 0. 10 minus 10 is a 0 over h, and then this is the limit of h approaching 0. Look at me, I am writing my limit of h approaching 0 as I continue with my simplification. So 0 divided by h is a 0, It's only at the final answer that I am not indicating the 0. The limit of h approaching 0, 0 is equals to 0 there. That means the f derivative of f at x equal to 10 is equals to f as 0. Mark allocation for this one is 1 mark for f at x plus h, second mark for substitution, the third mark for simplification for the 0, and the final mark. So the first principle is 5 marks minimum, grade 12. So you'll be having your 5 marks, and this question is in all your technical maths question papers. You'll be finding it on your prelim and on your final exam. And then now let's look at the second now example here. Determine f at f derivative using the first principle if f at x now is minus 7x. And then let me give you a tip, grade 12, around this one. You already have your answer. Your answer for this will be the coefficient of your x, of which in this case is minus 7. So after using first principle, we are expecting an answer that is minus 7. That will be our answer there. And then with the technical maths grade 12, we are only doing a constant and the x to the power 1. I've already indicated initially, or ax plus b. That means now it must be always x to the power 1, nothing else. Constant number without x, or x to the power 1. The minute you see x to the power 2 is not your syllabus. X to the power 3, not technical math syllabus. 2 over x, where x is the denominator on first principle, not your syllabus. Yours is the constant and x to the power 1. Right, and then you have f at x equal to minus 7x. We substitute to get x plus h. That is the method that we'll be following throughout. So for x, we substitute x plus h minus 7 bracket x plus h, because we are substituting for x. And then after substituting, you distribute minus 7, multiply in minus 7 times x minus 7x, minus 7 times h minus 7h. That means this is our f at x plus h, grade 12. And then from there, we go into the formula, f derivative of x, where the limit of h is approaching 0, of f at x plus h. Remember, you need to copy first the formula correctly from your formula sheet before you can do any substitution. And the next step, you can now substitute your f at x plus h, of which is minus 7x minus 7h minus, remember the minute it's a minus, and then there's a substitution. Remember the bracket, f at x is minus 7x from the given there. Okay, all over h. And then now we are going to remove the bracket. Limit of h approaching 0, of minus, we repeat everything as it is for the first two. And then negative by negative into the bracket, it will be positive 7x. And then divide by h. And the 7x minus 7x. Immediately after removing this bracket, grade 12, the next step, there must be terms that are cancelling, especially the one of f at x there. It must be cancelled. If it doesn't go out, remember there's a mistake. You must go back and double check. Okay. So now we are left with the limit of h. Let's continue this side. We are having the limit of h approaching 0. And then we are left with minus 7h over h there. Then the h will cancel h. We are left with limit of h approaching 0 of minus 7. Therefore, our answer will be minus 7. That is f derivative of x. Ensure that at the answer you do not write the limit on your answer, grade 12. It's only minus 7 there. And then now the first mark will be for the correct f at x plus h. Second mark for correct substitution into the correct formula. Number 3, it will be for simplifying that. And then number 4 will be another simplification where we are cancelling now the h. And then lastly, your final answer. So first derivative worth how many? 5 marks. The third example, Determine again derivative of this using first principle if f at x is equal to a pi minus x. Remember, grade 12, pi is not a variable, it's a constant number, which is 22/7 or 3.14 if it is rounded off to second, the estimation of the approximately, yes, approximately the correct rate. That is 3.14 for the pi. That means a pi is a constant number. It's a number, it's not a variable, right? It's a symbol that is representing 22/7. Okay, so now we are having f at x. So we want to come up with f at x plus h. That is your first step. F at x plus h is equal to pi minus x plus h, because wherever we have x, we are going to substitute with x plus h. F at x plus h, and then we leave a pi. A negative into the x is minus x, negative times h, it is negative h there. And then that is our f at x plus h, grade 12. And then now into the first principle formula, f derivative of x is equals to the limit of h approaching 0 of f at x plus h minus f at x all over h. After copying correct, double checking everything is correct, I can now substitute the limit of h approaching 0. F at x plus h is what? Pi minus x minus h minus the f at x, important bracket, grade 12, do not forget that. Then we can now substitute the f at x, which is pi minus x all over h. The next step, now we are removing brackets. Limit of h approaching 0, that is pi. We bring down the three terms as they are. And then now into the bracket, minus into a pi is minus pi. Minus into minus x is a positive x there. All over h. Look at that bracket, né? And these are the terms that comes from that bracket. They must all be cancelled or giving an answer 0. If they still remain on your solution to next step, you have done something wrong, grade 12. Look at this, x minus pi plus pi. It is giving you a 0. And then now let's see what is left now. We are looking at f derivative of x of the limit of h approaching 0. We are left with minus h over h. And in this case, h goes once into h there. We are still having the limit of h approaching 0. Remember, there's a coefficient 1 there, then this is minus 1. Our final answer is just a minus 1 without a limit, grade 12. So first mark will be for the correct first principle, f at x plus h, sorry. The second one, substitution correctly into correct formula. The third mark will be for simplifying that. Another simplification, and then your final answer, 5 marks, grade 12. And then this type of a question will be on your paper. One of them is already on your prelim, one is already on your final for 5 marks, grade 12. And then now we are done with the first principle. And then grade 12, if the question says use first principle, it's a must to use the first principle, even though you know that the rules of differentiation can give you the final answer. You cannot use the rules where it is indicated first principle. It's a must that you must use that principle. Okay, so now here we are looking at rules of differentiation. We will be differentiating still, but using the rules. Previously, we were differentiating using first principle. In this case, we'll be using the rules. Now, when we use the rules, still we'll be giving your f at x being a constant number. So you start deriving. If it's a constant number, can you see you'll still get a 0? We got a 0 even when we use the first principle, number 1 of first principle, if you still remember that. And then rule number 2 now, if you have given f at x being ax, then the derivative will be the coefficient of a. I've shown you with f at x. equal to minus 7x, that the answer will be minus 7. That is how we can identify our answer using the rules now. So that means the coefficient of that A will be your answer. And then rule number 3, now we are continuing with this one. If we are given f at x is a x to the power n, the rule says you'll be taking n, you multiply with an a, as you can see there. The first thing, you take exponent, multiply by the coefficient. That is what this means. And then from the exponent, you must subtract a 1. Then that is the application of the rule. We will be using this going forward throughout. Do not confuse this with integration. Remember, integration is to move from integral to derivative. Okay, here we are differentiating. That means integral is the reverse of the differentiation. So your problem is that you will be mixing it up. Integration, remember, the rules are already on your formula sheet at the back. You apply those rules. But with the rules of differentiation, you need to follow these rules. They are not the same, grade 12. Take care of that, okay? You will be penalized for incorrect formula or notation. I've already indicated that to you. Only one penalty for incorrect notation. And then now let's look at the examples now. Number 2.1, they say determine dx of minus 5. I've already talked to the notations now. We have a constant number, minus 5. What do we mean by a constant number? It's a number without an x. That means the derivative of that will be just equals to 0. Derivative of x minus 5, because it's just the number, the answer is 0. That is why it's 1 mark there. Okay, you don't write this dx again here, grade 12. If you go to the answer of the derivative, this notation, you get rid of that dx on your answer when you have derived now. And then now, number 2.2, we are deriving y, or we are given y is equal to x to the power 3 over 2 minus 4x to the power minus 7. Determine dy dx. That means this is telling you that derive y in terms of x, okay? So now let's see now. Do we have to simplify anything? No. The problem is straightforward. Y is equal to x 3 over 2 minus 4 x to the power minus 7. So it's coefficient multiplied by 1. Okay, the notation first, grade 12. The minute you start multiplying exponent into coefficient, you must tell us that you are deriving. That means by writing the notation dy dx, you are telling us now I am starting to derive. So it will be 3 over 2 times 1, which is 3 over 2 x. And then from the exponent, we subtract 1. Then we'll be left with 1 over 2 there. So that is your first derivative. For the second one, is minus 7 times minus 4. It will be positive 28. And then we have x. From minus 7, we minus 1. This will be minus 8. Then that is your answer, grade 12, right? The first mark will be for the first derivative, second mark for the second derivative, and then we stop there. If maybe an examiner indicate to you that we need answers with positive exponent, especially for the second one, you'll write this as 3 over 2x to the power half plus 28. And then you take this x to the denominator to change its exponent to a positive exponent. But grade 12, if you are not comfortable with that, please remain at the second step there. So to avoid mistakes and losing marks unnecessarily. And then with 2.3 now, we are determining the derivative if f at x is equals to 2 square root of x minus 3x to the power minus 1 plus 4 pi, right? We have a challenge because we have a root sign there. We need to get rid of that set notation first, then we'll be having still f at x. We are not deriving, we are simplifying. So we don't indicate anything on the f at x. So it will be f at x 2x Remember, the square root is to the power half. So we write this in exponential form, minus 3x to the power minus 1 plus 4 pi. Remember, 4 pi is a constant value, right? It is not a variable, it's not a letter, it's a symbol representing 22/7. Therefore, it's a value, right? And then f derivative of x is equals to, now we are saying we are deriving by that notation with a dash there. So let's derive. Half times 2, half of 2 is 1. Then you know the coefficient 1 we normally don't write, but you know there's a 1 there. And then half minus 1 is minus a half. Negative 1 times 3 is positive 3. Minus 1 is minus 2. X to the power minus 2. This one is a constant number. The derivative will be 0 because it's a constant number. The mistake that you do, grade 12, you write plus 4 as if pi is a variable x. No. Please take care of that one. So now, if the examiner wants you to get rid of, but I am saying to you, you can stop there if you are not comfortable with changing this to a positive exponent. Changing to positive exponent, we leave that 1 on top, and then below we have x to the power half. Plus, we leave 3 on top, and then x squared goes to the denominator and now becomes positive. Allocation of marks, it will be 1 mark for changing this set into its exponential form. The second mark will be for the first derivative, the third mark for the second derivative. That is how we allocate the 3 marks, grade 12s. And then 2.4.1, determine the derivative if f at x is equals to bracket x squared minus 3 over x squared. Before you derive, you look at your problem. Is it simplified? No. Number 1, we have bracket with exponent 2. Number 2, we have x in the denominator, that is the variable. So we need to remove those two things because before we can start deriving. So before you derive, you ensure that you check the terms. So now we are not yet deriving, we are simplifying now. We have f at x is equal to, this means 2 brackets of x squared minus 3 over x. Exactly the same, grade 12. Do not change sign to plus minus. This is not difference of 2 squares. This 2 means 2 brackets of the same thing. So this will be x squared minus 3 over x again. And then let's multiply out. It's x squared times x squared. That is x to the power 4. And then x squared times a 3 over x, that will be 3x because x will cancel 1x there, and then you'll be left with minus 3x. The same applies, minus 3 over x times x squared, it will be minus 3x again. And then minus 3 over x times minus 3 over x, it will be positive 9 over x squared. And then now, let's simplify this further. It's x to the power 4 minus 6x plus 9 over x squared. Okay, we can take this x squared automatically to the top. It will be x to the power minus 2. Remember, we must not have variables on the denominator there. Okay, now we can start deriving grade 12. This will be f derivative of x. And then it's 4 times 1, which is 4. X to the power, subtract 1 to the power 3. And then if it is x to the power 1, the coefficient is the answer, minus 6. With this one, minus 2 times 9 is minus 18. And then x, subtract 1 from the exponent, it becomes minus 3 there. And then it's 1 mark for simplified trinomial there. Second mark for the derivative. Third mark derivative. And the fourth mark for another derivative. That is why this problem is worth 4 marks, grade 12. Okay. 2.4.2, another type now. In this case, we are given an expression on top. It is divided by x. All these terms are now divisible by x. So we are going to separate this to its original. because this simply means now the denominator x is for each and every term there. We have taken that as LCM x, so we reverse it back to its original. So originally this was dx. We keep the notation because we are not yet deriving, we are simplifying. That will be 2x to the power 4 over x plus x cubed over x minus x over x plus 3 over x, close bracket. Now each term we have taken the x, and then now we continue simplification. Now d over dx, and then the x goes once there, or same base, you subtract exponents, it will be 2x to the power 3. And then x goes once there, you are left with 2, then it will be plus x squared. And then the x into that one once. And then we have plus 3, we take x on top, it will change to x to the power negative 1. Right, grade 12. Now we are done with simplification. We can start deriving now because you don't have any like terms to add, right? So now let's start deriving. The minute you start deriving with this notation, this dx will disappear. It will only be 3 times 2, of which is 6. That is the correct notation. X, subtract 1 from the exponent, 6x squared. We are applying the rule now. The rule says 2 times 1 is 2. Subtract 1 from the exponent is to the power 1. Minus 1 is a constant number, the derivative is 0. And then minus 1 times positive 3 is negative 3. X to the power negative 1 minus 1, it's a minus 2. And then now grade 12, that is your derivative for that particular answer. So this problem, when it must be 4 marks, it can't be 5, it's too much for that. And then it's 1 for simplifying, and then for the first derivative, second, and the third derivative. So this is worth 4 marks, grade 12. And then 2.4.3, we are given the x notation now is x cubed minus 1 and the x minus 1. If you look at this now, you need to factorize and simplify. We still need to simplify because, again, there's a variable on the denominator, but the application here is not the same as that one. In this case, it was only x. That is why we separated. In this case, we have a binomial, 2 terms in the denominator. If that is the case, grade 12, we cannot apply this method. It must work only with 1 term, this one. So here you need to check at your factorization on the top part there. We are going to derive that cube. Then this is the difference of 2 cubes. So now when we derive this one on top, you'll be having cube root of x is x, cube root of 1 is 1. And then now this is your grade 10, grade 12, grade 10 factorization. Go and check all your factorization now. You square the first term is x squared. Multiply the first by the second minus x. If it is minus, it will be plus x this side. And then you square the last term plus 1. That is the method, grade 12, of factorizing a cube. And then all over x minus 1. And then now this x minus 1 will cancel an x minus 1. You will be left with the x of x squared plus x plus 1. Now we can start deriving because we don't have any challenge anymore. The minute you start differentiating now, the dx will disappear. That is the correct notation, grade 12. Do not do a mistake. On your answer, this dx will never appear there. So you only have 2 times 1, of which is 2x, subtract 1 to the power 1. And then remember there's the 1 there. We take that coefficient because x is to the power 1. We will only take a plus 1. The constant value 1, a derivative is 0 there. Then that is your answer. First mark will go for factorization on the top there. The second mark for simplifying the brackets and end up with x squared plus x plus 1. And then now the first derivative and the second one. This must work 4 marks, grade 12 in order to satisfy your solution. Okay. And then now we are going now, increasing the level, grade 12. We are given that y minus yx is equal to x squared minus 1. They say make y the subject of the formula of the equation and simplify completely. So now we are taking our equation. We want to make y subject of the formula, but y appears here and there. That means now we need to take y as a common factor on the left. Then if you take it out, it will be left with 1 minus x then. And then on the right hand side, you have x squared minus 1, of which is the difference of two squares factorization. So now we are going to have two brackets of the same thing. The other one must be negative, the other one positive. So we have x squared there will share xx, and then 1 is 1, 1. 1 times 1 is 1. Okay. And then after factorization, now you can see that you divide by 1 minus x this side, and also 1 minus x that side. 1 minus x will cancel that one. And then on top, we are having x minus 1 with the x plus 1. We are still simplifying, great terms. But if you look at the denominator now, the 1 is positive and x is negative. If you look at the one that we have on top, is either way around. X is positive and the y is negative. So we are going to take out a negative from the denominator so that it can appear as the numerator one. So x will change and be positive inside bracket, and the 1 will be negative. Because now if you bring back this negative, it will be minus x and the positive one, of which is the same term. So x minus 1 will cancel x minus 1, so we are left with y is equal to a negative into x plus 1, of which is minus x minus 1. Okay, and this is worth 4 marks, great term. The first mark will be for factorizing the left-hand side, second mark for the right-hand side. The third mark is for simplifying. The final mark is for the final answer, minus x minus 1. And they say hence. The minute you see the word hence, it says use the previous answer. So by using the previous answer, they say take y minus x minus 1. And then determine dy dx of that. So we are deriving y in terms of x, and then this is to the power 1, then you take coefficient minus 1. It's a constant value, then the derivative will be 0. Then that is your answer, grade 12. That is why it is worth a 1 mark. And then another one, and then we are given y is equal to t squared minus 4 over t minus 2. Okay. And then now, in this case, they say simplify y. Now, if you look at y, on top here, we are having difference of 2 squares because 4 is the same as 2 to the power 2. The difference is the number we get when we subtract 2 squares, t squared and 2 squared. Difference of 2 squared. If that is the case, grade 12 will be having the brackets of the same thing. The other one will be negative, the other one positive. And then we have 2 t's there, it will be t squared, and then 2 squared will be 2 there. And then on the denominator, we have t minus 2. Then the t minus 2 will cancel t minus 2. We are left with y is equal to t plus 2. So the first mark will be for factorizing, and then the second mark for simplifying. Hence, that means take your previous answer, determine dy dt, deriving y in terms of t, okay? Then this will be dy dt, dt not x, dt, deriving y in terms of t. And then this is to the power 1, that means you are taking coefficient 1. This is a constant number, the derivative is 0 there. So your answer will just be 1. That is why this is worth 1 mark. And then grade 12, that is your activity. Look at this. This is on first principle. That means you must use your formula from the formula sheet, of which states that f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x all over h. And then now you need to simplify this. This is 5 marks, grade 12. I am giving you 3 minutes to complete this activity. Your 3 minutes start now. Okay, great, Charles. Let's see how far did you go with this one. You are determining the derivative using the first principle. If f at x is equal to the 2 pi minus 3x. Remember, you have your f at x, where you have x now, you are going to substitute that with x plus h. That is your first step. It will be f at x plus h equal to 2 pi minus 3 into x plus h. Right, and then simplify, remove brackets. It will be 2 pi minus 3 times x minus 3x minus 3 times h minus 3h. That is our f at x plus h. Into the formula, f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x all over h. Limit of h approaching 0, f at x plus h, we are substituting it from here. That is 2 pi minus 3x minus 3h. Negative important bracket, that is 2 pi minus 3x. And then all over h. Simplify the bracket, limit of h approaching 0, the 2 pi minus 3x minus 3h, we are bringing it down as it is, and then the minus into 2 pi is minus 2 pi minus negative 3, that is positive 3x, all over h. Remember, I said to you, after simplifying this bracket, it must be subtracted, cancelled on next step. That is 3x minus 3x. Can you see the 0? A 2 pi minus 2 pi, it's a 0 there. Then you are having the limit of h approaching 0 minus 3h over h. That means from this step, grade 12, you must be left with only what is having h. The minute you have an extra number there, you must know you are going wrong. So h divided by h will be equal to the limit of h approaching 0 of minus 3, of which is just a minus 3. So the first mark will be for f at x plus h substitution, the simplification, another simplification, and the answer there. This is worth 5 marks, grade 12. Your next activity, we are using the rules now. If they say determine without indicating the rules, that means you need to use your rules now. If it is not indicating first principle, you must know you need to use the rules to answer that one. So now here we are giving dx of x squared minus x to the power minus 3 over 2 over x. It's your activity, grade 12. I am also giving you 3 minutes to complete that particular activity and reflect back after 3 minutes. Try this one, your 3 minutes start now. Okay, grade 12, remember our WhatsApp number 079 578 If you need some clarity on something you do not understand, please share on that WhatsApp group. Right, let's look at our activity now. Remember now, you check first. Can you derive? No. Why? Because there's an X on the denominator there. And then how many? Terms only one. That means it's where you will separate, right? And then now, since we are simplifying, we will still write that dx because we have not yet derived. We are busy simplifying. So x squared will take the denominator minus x to the power minus 3 over 2 will also take a denominator x. Still simplifying, we write a dx. And then x into x squared, it goes only x to the power 1. Or you can say same base, we subtract exponent. Minus same base, and then it's minus 3 over 2 minus 1. That will be minus 5 over 2. Use your calculator, grade 12. Do not just assume answers. Verify your answers by using your calculator, especially when you are subtracting these exponents, right? And then now the next step, happy now, we don't have any variables in the denominator. We can now start deriving. Then this is to the power 1, x to the power 1, we take the coefficient 1. As long as we are having x to the power 1, the coefficient will be your derivative. And then now this is 1. And then for the next one, it's a negative 5 over 2 times negative 1 is a positive 5 over 2. And then from the exponent x minus 5 over 2, we subtract 1. This will give us minus 7 over 2. You can stop there, grade 12, it's fine. Or if the examiner is forcing that the answer must be on positive exponents, the answer must be 1 plus, remember you have 5 over 2 as denominator. So this x to the power minus 7 over 2 is on top. Now we take it to the denominator to join these two. It will be x to the power positive 7 over 2 because we have changed the position from numerator to the denominator. Then the allocation of marks, it will be for simplified form from that one, and then for the first derivative and the second derivative, which is 3 marks then. And then the last activity for you, again, grade 12, still on application of rules now. We are giving a different example. And then this is your last 3 minutes on this activity now. Your 3 minutes start now. Okay, grade 12, let's see now. You are deriving y in terms of x. In this one, they didn't guide us, but we know that you cannot derive y, whereas it is in mix of other variables like that. So you must first make y subject of the formula on your own, even if you are not guided. That is your starting point, right? Fortunate enough, nowadays, they scaffold the question start by saying to you, make y subject of the formula, and then now find dy in terms of the x. Unfortunately, here we are just indicated that you determine dy dx. If that is the case, now you must start by making y subject of the formula. As you can see, y is common there. We are going to take y out as a common factor. And then when you take y out, you're left with x. You take y out, you are left with plus 4 there. And then on the right hand side is the difference of two squares. Why are we saying these are squares? Because 16 is 4 to the power 2 also. And then now this will form two brackets of the same thing. The other one will be minus, the other one plus. So this x we share xx, and then the 4 squared we share 4 4. And then now we divide both sides by x plus 4 because we want y being the subject of the formula. And then x plus 4 will cancel, x plus 4, you are left with y equal to x minus 4 because the x plus 4 will also cancel x plus 4, that's it. And then to derive this, we are having dy dx. Can you see now, before you come here, it must say y equals to only one y appearing so that you can derive y in terms of whatever we have on the right hand side. So this is x to the power 1, then you take coefficient of x, of which is 1. The derivative of a constant value is equal to 0. So the answer will be 1 for the derivative. So the first mark is for factorizing the left-hand side, the second mark for the right-hand side factorization, and the final mark for the correct derivative, of which is worth 3 marks for that. I hope everything went well with you, grade 12, on this particular activity. Now we move to the equation of a tangent. To determine the equation of a tangent, remember a tangent is a straight line graph, okay? And then to determine the derivative using the rules of differentiation, that means number 1, you need to determine the derivative using the rules of differentiation. That means f a derivative of x if we are given f at x then, okay? And then after doing that, you substitute the x coordinate of the given point. The x coordinate, if we are given x is equal to a, that means you take that derivative that you have calculated above, you substitute that x value now. Thirdly, you substitute the gradient of the tangent and the coordinate of the given point into the original straight line equation. So you take the straight line equation now. That means now grade 12 number 1. By so doing here, you'll be having the gradient of a tangent. Do you see that? And then now you have the x value there. If you do not have the y value, you must substitute this a into original here. It will give you the y value. Then you'll be having your coordinate a and the y value that you have calculated. Then you have a gradient and a point. Then you can substitute into that equation. If you are using y equal to mx plus c, of which is the first one there, you calculate the value of c in order to find the equation. And then how do you do that? You substitute, you calculate the value of c, and then you substitute back into the equation in terms of, and leave your equation in terms of x and y. And then using y minus y1, remember, you simplify and make y subject of the formula. After substituting everything, you simplify until y becomes the subject of the formula for the second equation. For this one, you apply the method of a gradient and a point. You substitute your gradient and a point to find the value of c. Okay, so those are the two applicable equations to find the equation of a tangent. And then here we are given if h at x is equal to x squared minus 5x, determine h at minus 1. What do they mean about it? They mean where you are having an x now, remove x and substitute x with the minus 1. That is what they mean about it. So we are going to take our h at x squared minus 5x. Wherever we have x, we are going to substitute with the minus 1. Minus 1 squared minus 5 minus 1. And then this will be equal to a minus 1 squared is a 1, minus 5 times is minus 1, it's a positive 5. So the answer will be 6 for that. That is your h at minus 1. Only 1 mark for that. And then h at 3, it means take your h at x, wherever you have x, substitute at 3. Minus 5, substitute at 3. That means we are substituting wherever we have x greater. And then now 3 squared is 9 minus 15, for 5 times is 3. And then the answer would be minus what? Minus a 6. H at 0 means substitute 0 for x. That will be h at 0. We are substituting x with a 0. Squared minus 5x with a 0. And then 0 squared is 0. 5 times 0 is 0. Then the answer would just be a 0 for that one. And then lastly, we are looking at h at a. That means we are substituting our x with the a now. This will be h into a equal to x is a squared minus 5, substitute x with an a. And then this will be a squared minus 5a. That is our h at a. All of them, they only were 1 mark, great jobs. We are given the g at x is equal to 3x squared plus 5x, and then at 3.2.1, you need to determine the derivative of this function, okay? Because it is saying g derivative of x. So we are going to derive g at x, and then it will be 2 times 3, which is 6. Can you see the application of your rules now? That is 6x on the exponent to subtract 1, it will be to the power 1. This is to the power 1, that means the answer is the coefficient there, that is plus 5. That is your derivative, great job. 1 mark for that one and 2nd mark for the second one. And then for 3.2.2, determine derivative when x is equal to minus 4. That means this is saying to us, substitute minus 4 in your derivative equation. Okay, so this is the derivative equation. That means we will be substituting a minus 4 into that equation. Where we have x, we are going to substitute with minus 4 plus 5. By so doing, great job, deriving and substituting the x value at a certain point, you are looking at the gradient of a tangent to this particular function that was given to you at the point of contact. At that point of contact, x is equal to minus 4. Then the value that we'll be getting here, it will be the value of your gradient, of which is minus 19 for that equation of a tangent. Then this is 1 mark for minus 19. And then 3.2.3, hence determine the equation of the tangent to g at x equal to minus 4. Now, remember you need an equation of a tangent, and a tangent is a straight line. Now, to find the equation of a straight line, you need a gradient and a point with x and y. Let's check, do we have everything we need? Do we have a gradient? Yes, we do. Our gradient of a tangent is equal to minus 19. Do we have a point? No, we only have the x value, which is minus 4. We need the y value that will coordinate with that minus 4. How will you get that y value? You are going to substitute this x value into original, then it will give you the y value. Let's do so, great job. Remember, g at x represents y, and then this will be 3x squared plus 5x. We are now going to substitute an x with a minus 4 to get the y value. X is minus 4 And then into your calculator, remember there's a square there. Into your calculator, grade 12, straight to the answer. We are getting a y value that is equals to 28. Happy now. We have x value and the y value of which is x minus 4 and the y value equals to 28. We have all what we need, the gradient and the point on that particular graph. Then we can find the equation of this particular graph. Let's say the first learner now decided to use y is equal to mx plus c. The learner will substitute this as x and y. Then y will be 28, and the gradient is minus 19, and the x will be minus 4, and the plus c. That means we are looking for the value of c now. This will be 28 into minus 19 minus 4, which is 76, plus c. Then the c value will be 28 minus 76, which is minus 48. And then this gives us an equation of y. We are now substituting in the original. M is minus 19x. You leave x and y and substitute c, minus 48. That is the equation of that particular graph. Or alternatively, another learner may decide to use the equation y minus y1 is equal to m into x minus x1. And then with this learner now, we'll call this x1 and y1. Okay, and then this will be y minus y1 is 28, and the gradient is minus 19 into x minus x1 is a negative 4. So this negative with that negative, they will form a positive 4. And then now we end up with y minus 28 equals to minus 19x. Minus 19 times 4, which is 76. And then now we end up with y is equal to minus 19x. Minus 28 to this side becomes positive 28. Minus 76 plus 28, it will be a minus 48. So grade 12, basically, these two learners will end up with the same answers. So the first mark goes for the value of y. The second mark goes for substitution into the correct formula. The third mark will be for the final equation. The same applies here. It will be for the value of y, the substitution, and the equation. So these problems were 3 marks. And then now, next 3.3, determine the coordinates of the point of contact between a tangent with a gradient equal to, we are given a gradient here of a tangent. That means m of a tangent is equals to 12 according to the statement. Okay, we are looking for the point of contact. We are looking for the value of x on y. And then this tangent is a tangent to the curve of f at x is equal to 2x squared minus 1. That means grade 12, basically we are given this formula. You are also given the gradient of a tangent there. So we use the knowledge that we have now. To find the gradient of a tangent, remember we were looking at the derivative of the function, of which it will be 2 times 2, which is 4x to the power 1, and then minus 1, it's a 0 because of being a constant. Derivative of a constant, it's a 0. So we are given that the gradient, remember this side represents the gradient of a tangent after deriving. Okay, so now we put in 12 for the gradient, then we have 4x there. Can you see now you can now have your x value, divide by 4 both sides, then x will be equals to a 3. Happy grade 12, and we now have the x value. We are now left with the y. To get the y, the same method, to take this 3 into original, it will give you the y value. Remember this f at x stands for y, and then this is 2x squared minus 1. We are going to substitute x value now. This will be 2 into 3 squared minus 1. And then 3 squared is 9. 9 times 2 is 18. 18 minus 1, that is 17. So that means therefore coordinates of this will be 3 coordinating with a 17. And then this is worth 4 marks. The first mark will go for the derivative. Second mark for equating the derivative to the gradient. The third mark is for the x value. The fourth mark being the y value. And then if it says in coordinate form, grade 12, your answer must be in coordinate form. Notation of coordinate 3:17. 3.4, the equation of a tangent to the curve of g at x equal to, this is the function given to us, g at x is equal to mx squared plus nx is y equal to x plus 2. This is the equation of a tangent, okay? This is the equation of g at x that is given to us. And then if the point of contact is 1 and 4, that means these two graphs, they have a point of contact at 1 and 4, where they have a tangent. Calculate the values of m and n. Okay, now, we can take this equation. Look at this, we are calculating two unknowns. The minute we have two unknowns, this is calling for simultaneous equations. The minute you need to solve simultaneously, you need two equations. So you're thinking grade 12 must be around that information. So now let's start by creating the two equations. For the first equation, we are going to substitute this into the original g at x equal to mx squared plus nx. And then this will be x and y. Remember, this part represents y, it will be 4. And then mx is 1 squared plus nx is 1. Then we have a 4. 1 squared is 1 times m is m, plus n times 1 is n. So you can either make n subject of the formula or m, okay? So I am taking m to this side, then I'll be left, this will be 4 minus m equals to n this side. Then this will be my equation 1. Now, happy we have the first equation. To find the second equation, we have the equation of a tangent. And the gradient of this equation of a tangent, remember gradient is the coefficient of x there, is equals to 1. So now to find the gradient of a tangent, we derived the formula in order to end up there. So we are going to derive this g at x. You look at g derivative of x is equal to now 2 times m is 2m x to the power 1 because you subtract 1. This is x to the power 1. The derivative will be coefficient n. Okay. And then now remember this, the gradient is at x equals to 1. So now we are going to substitute this derivative with 1 now, so that we can get the gradient of this particular problem. Then the minute you have substituted a value there, this is now a gradient of a tangent, of which is 2m plus n. So what is the gradient of a tangent according to that equation? This is equals to 1. 2m plus n. Okay? Remember, this one that we have substituted is from the gradient, not from that point. No? It's from the gradient because we are having derivative there. So now from equation 1, we have n is equal to 4 minus n. This is our equation 2. Then we are going to substitute equation 1 into 2. So our equation 2 is this one, grade 12. So we are going to, where we have n, we'll put 4 minus n. So it will be 1 equal to 2m plus the n is 4 minus m. So 4 to the side is negative 4 plus 1, negative 3. 2m minus m, it will be m. So the m value will be equals to minus 3. So to get the n value, we are going to substitute m there. It will be 4 minus 3, which is plus 3. Then n will be equal to 7. So the actual equation of this g at x, it is g at x equal to minus 3x squared plus the 7x. That was the actual equation for that. And then now let's put the values now. The first value will be for the first equation, the second one for the second equation, the third one for the value of m, the fourth one for the value of n. If they say determine the equation of this now with real values, you'll end up there. Okay, we are just covering everything for you, grade 12, so that now you know exactly how to answer these questions. And then now in this case, you are determining the equation of a tangent to the curve f at x equal to x equals to 1 at x equals to 1. Determine the equation of a tangent of this function when we are given x equals to 1. Do you still remember the method? In tangent, it's a straight line. You need a gradient and a point. In this case, you have only x equal to 1. To get the y value, you substitute this into original, you'll be having your y value. Then we'll be looking at f at 1 into 2 into 1 cubed plus 3 into 1 squared. And then this will give us the y value, which is 1 cubed is 1 times 2 is still 2 plus 3, which is equals to 5. Then this is y. So this is coordinating 1 and 5. That's the first thing. We have a point. And then now for the gradient, you are going to derive. So it's f derivative of x to find the gradient of a tangent. 3 times 2, it's a 6x, subtract 1 from the exponent to the power 2. And then 2 times 3, it's a 6x, subtract 1 from the exponent is to the power 1. And then now we are looking at x equals to 1, derivative at a point of contact where x is equal to 1. This is 6 into 1 squared plus 6 into 1. And the minute you do this grade 12, we are looking at the gradient of a tangent, of which it will be 6 plus 6, which is 12. So you have your gradient, and then you have your point. You can now find the equation of the tangent. If you decide to use the equation y equal to mx plus c, is up to you, learners. Which one is simpler for you? Then you'll say this is my x and this is my y. What is y? 5. What is the gradient? 12. What is the x value? 1 plus c. Then this will be 5. 12 times 1 is 12 plus c. Transpose 12 to the left, then it will be minus 12 plus 5. And then this will be minus 7. So the real equation now will substitute m and c and leave x and y because it's an equation. So m is 12x and the c will be minus 7. That is the equation of that particular function. Or if you use y minus y1 equal to m into x minus x1, and then now this will be called your x1 and y1. So this will be y1 is 5 equal to gradient, still using 12, and then x minus x1 is minus 1, and then you have y minus 5 is equal to 12x because you are multiplying 12 in, 12x minus 12, and then y is equal to 12x minus 12 plus 5 minus 7. Exactly the same formula as grade 12. It's up to you, you choose which one. And the first mark will go for the y value equal to 5. The second mark will go for the derivative, the third mark for the tangent. And the fourth mark will go for the substitution into the correct formula there. And the fifth mark will be for the solution there. It's for the x value, it's for the derivative, for the value 12, for substitution into the formula, for the correct c value, and then for the equation of your graph. At least here you would have collected 6 marks, grade 12. And then last activity, determine the coordinates of the point of contact now. Coordinates of the point of contact, you are looking for x and y, of a tangent to the curve. This is the curve given to us. At the tangent of a gradient of a tangent being 6, then m of a tangent is equals to 6. Okay, we need x and y. We are given a gradient, then we start by deriving f at x because we are given a gradient. 2 times 1 is 2x to the power 1, and then coefficient of minus 2x is minus 2. And then now we are given this. Remember, after deriving, it is now a gradient of a tangent. So now what is the gradient of a tangent? 6, 2x minus 2. Then 2x, you transpose minus 2 to the side, it will be 6 plus 2, of which is 8. And divide both sides by 2, then you have your x being equals to 4 there. Happy now, you have the first value there being a 4 for the x. And then now to get a y, you take x into original. Still remember that? Then you'll get your y value. That is always what you do, grade 12, when you need to find the y value when given x value in all functions. So this represents f at x, then we'll put y for that, because f at x represents y, and then x squared minus 2x. Substitute x with the 4 value, then this will be y equal to 4 squared minus 2 into 4. And then 4 squared is 16, minus 2 times 4, 8. And then 16 minus 8 is equals to just an 8. Because they say coordinate, then the answer will be 4 and 8 being in coordinate form, grade 12. And then this is your homework. Now it's the same application, first principle, your rules, and the equation of a tangent. You can try this on your own, grade 12, and check how far will you go with this one. And then now the summary of our lesson, differential calculus, we looked at first principle, rules of differentiation, and then we also looked at the equation of the tangent using the first principle equation, using the rules, and then finding the equation of a tangent as being the straight line equation or the straight line graph, okay? And then now our preview for the next lesson, grade 12, just in time. You will be with us again on the 13th of August, the next Wednesday, and then from 2:30 to 4 o'clock. And then we will be looking at the topic integration. Thank you very much, grade 12. This lesson was brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. See you next week, grade 12. Bye.